I just said that at its core, Git is a map. That means that it's a table with keys and values. What are the keys and what are the values? Well, the values are just sequences of bytes. For example, the content of a text file or even a binary file. Any sequence of bytes can be a value. You can give a value to Git and it will calculate a key for it, a hash. Git calculates hashes with an algorithm called SHA-1. This is one of those technical names that nobody seems to agree how to pronounce. You might hear people call it SHA-1 or SHO-1. Other people call it shown, that I think is nice because it kinda rolls off the tongue, so I'll call it shown. Every piece of content has its own shown hash. For example, let's take a piece of content, the string apple pie. If you ask Git to generate a hash out of this string, then you will get this hash. Exactly this one. There is only one hash for this string. Shown hashes are 20 bytes in hexadecimal format, so they are a sequence of 40 hex digits. This will be Git's key to store this content in the map. We can also calculate the hash on the command line. To do this, we need a command that you might never have heard about because it's a low-level plumbing command, git hash object. So let's pass our piece of content to hash object. I wish I could do it like this, it would be simple, but I can't. Hash object is not very user-friendly. It's a plumbing command, so if you do what I just did, Git will think that apple pie is the name of a file. Instead, I can use the echo command to output this content and then pipe the result into hash object like this. I also need to tell hash object to get its content from standard input. Not very intuitive. By the way, if you're using Windows, then you will use slightly different shell commands. But don't worry too much about that. I'm not asking you to send this command yourself necessarily. It's enough that you understand what it does. It prints out the hash for this piece of content. And here is the result. This is the hash for the string apple pie. This is the same hash I showed you on the previous slide. We have the same content, so we get the same hash. If you change anything in the content, a single letter, for example, I will add a new line character at the end like this, then you get a completely different hash. Speaking of Windows, one thing you might find confusing is if you do send the equivalent command under Windows, then you'll get a different hash. But that isn't because there is any difference in git hash object or the hashing algorithm. It's just that the echo command behaves differently under Windows in a few ways. In particular, it doesn't strip away these quotes, it considers the quotes a part of the string, and it also adds a new line at the end of the string. So, long story short, you're actually hashing a different sequence of characters under Windows. But that doesn't matter in general, it only matters for this specific example because we're using echo to generate the sequence. In general, if you pass the same sequence of bytes to hash object, then you get the exact same hash every time, on every operating system. And each object in a Git repository has a shown hash, like this. If you put the string apple pie in file and store this file in Git, then the hash we just generated will identify the file. And as we'll see later, directories also have their own hash, as do commits, and so on. With so many hashes around, you might wonder what happens if they collide. After all, the number of possible hashes it's large, sure, but it's not infinite. What if I have two different pieces of content and just by chance they happen to have the same hash? Wouldn't that make a mess of my project and cause me to lose my data? Well, yes, it would, but it's unlikely to happen. Let's see just how unlikely it is, just because it's fun. Think of the US Powerball lottery. How many chances do you have of winning the lottery jackpot? Google tells me that the chances that a particular combination of numbers wins the jackpot are about 1 in 175 million. This is a large number, so let's try to visualize it. Imagine printing one ticket for every possible combination of numbers in the lottery. You get 175 million tickets. Now put all these tickets in a line, one every 25 centimeters, about 10 inches. That's a very long line of tickets, long enough to span the equator. Now imagine starting somewhere on the equator and taking a walk around the world. It's a long walk and also quite a bit of swimming, so it's going to take a while. You are walking along this very long line of lottery tickets, remember. And just once during your trip, you are allowed to pick up a single ticket. And if you are really lucky, that's the one ticket that wins the jackpot. Congratulations, that's how hard it is to win the jackpot. Now imagine that you enjoyed winning the jackpot, so you want to try it again. You take a second trip around the world, you once again pick up a single ticket along your way, and you win again. Now that's really good luck. Winning the jackpot twice in a row is almost miraculous, matter of fact. Now imagine doing it a third time, and amazingly you win again. And again and again, 6 times in a row. Now, winning the jackpot 6 times in a row is extremely unlikely, you will agree. Well, going back to Git, these are about the same chances of getting the same hash for 2 different pieces of content. It's just not likely to ever happen to you or to anybody by chance, so for all practical purposes, shown hashes are unique. Not just unique in your project, you can think of them as if they were unique in the universe. You could put all of the data you will ever write in your life in the same Git repository, and Git would assign a different hash to each version of each file in each folder. That's a lot of data. You might get some performance problems. Okay, you probably will, but still no collisions. Later in this training, when we talk about distribution, this notion that hashes are unique in the universe will come useful. For now, I'm only mentioning it to say if you have ever worried that 2 hashes might collide in your Git project, then no need to worry about that.